time for a little kitchen table astronomy with Hampshire College astronomer Dr. Salman Hameed. Mr. Universe, I'm at your Amherst kitchen table, but I can't see you because we're so excited about the eclipse a week from today that we both got our eclipse glasses on and they are remarkably dark.
Well, I can't see it either. Let me.
All right, we'll take them off.
And plus, I have to use my glasses to read.
Oh, yeah, your reading glasses.
But anyway, yes, eclipse is next Monday, April 8th.
It'll be happening during the course of the fabulous 413 between 3 and 4 p.m.
That is right. And so if you are, again, on the fence about it, I always feel weird about this because, because a lot of people cannot go to the path of totality.
Right.
Here in the Pioneer Valley, you will get about 95% of the eclipse, meaning to say the moon will not cover the entire disk of the sun, but it will cover 95% of it. And there are, UMass Amherst, for example, is doing a wonderful event at Sunwheel and Metawampe Lawn, and that's on UMass campus. You can go over there, and they will have solar glasses as well. If you don't have them already, you can get them as long as supply lasts, so keep that in mind. And here, if I get it right, I mean, I think in the local area, it's going to be, the totality is around 3:30 or 3:25, 3:30, something like that. So do check the local time. And the reason I don't have with me on my notes the really local time is because I have Burlington time, where is totality, and I can give you that, which is 3:26 p.m. And it's going to last for about 3 minutes.
Almost as long as Bonnie Tyler's song Total Eclipse of the Heart.
That's right. And I am planning on going to Dallas, Texas, where it's going to be a little earlier, and it's going to last close to about 4 minutes. And but we'll see. We just hope that it's not going to be cloudy.
That is a big deal. And that is why you're going to Dallas, because you think the odds would be better that there would be better weather and clearer skies so you could actually see the eclipse as opposed to just experience the darkness. But you were saying that the New York Times has a handy-dandy weather eclipse app.
Yes, and let me dry my tears first about this because it looks like that it's going to be cloudy right now. And again, long-range forecasts are tricky, but right now it looks like it's going to be cloudy pretty much in the entire path of totality in Texas. And I know there are a lot of astronomer friends are also going there. So, but New York Times, and there are other places as well, but New York Times has happily sort of has a visual aid over there, which gives you the prediction right now of how much cloud cover is going to be in the path of totality. You can go, you can zoom in, you can look at Burlington, you can look at Rochester, New York, you can look at Indianapolis, you can look in Dallas, Austin, and all other places. So that's a very good site. But just keep in mind, right now, it's still several days away, but panic has begun.
Yeah. Get these eclipse glasses that we have right here soon. I remember last time there was an eclipse, there was a scramble for them. They're like the most valuable thing for 3 minutes, and then the next minute they're useless. But most gas stations, I've noticed, and like hardware stores have these glasses.
But make sure these are the right glasses. It's very crucial. So in terms of eclipses, one of the rules, do not look at the sun without these solar glasses when it's partial eclipse.
Unless you have total immunity because you're the president of the United States.
You can get permanent eye damage. Do not. So that's the first thing, okay? Second thing is try to get the glasses that are certified, the solar eclipse glasses. You can find, like the American Astronomical Society has a great link to that. So go to their website and find glasses that are authorized. And that is, again, your eyes may be useful, and so
as we just experienced by putting eclipse glasses on here at your kitchen table when there's not an eclipse. Couldn't see anything.
And that's how it should be, right? So just make sure you have that during totality. So this is only for 3 or 4 minutes or 2 minutes or whatever the total eclipse is. Then you should take off your glasses because otherwise you won't be able to see the cool, amazing thing that the sun has been blocked by the moon. At that time, it is totally fine to look at the sun without your eclipse glasses.
So what should you like set an alarm to know when the exact right time is going to be? How do you know it's the exact right time? This is not something you want to screw up.
Fear. I think fear would be the right alarm. Like, you look at, you can use the alarm, you can do other things, but just make sure, that because as soon as it starts to come out, your retina is actually wide because it has been dark. But then as immediately the sunlight starts to come in, so it is not prepared for this burst of light that is going to come right after that. So make sure that you don't do that. That said, don't be afraid of it. It is an amazing phenomena. But if you are when it's partial eclipse, if you are not during the total eclipse time, use only your eclipse glasses to look at the sun. If you don't have that, there are other possibilities also. You can create a pinhole camera using serial box. Again, you can look at how to build a pinhole camera. NASA has these websites too.
I'll also say that pretty much every library that I've seen or driven by has a sign out about some activity they're doing about the eclipse, making these type of pinhole cameras. I know that one of our underwriters, PV Squared, is doing a thing at the Greenfield Library. I know the Turner's Library. I just drove by the Sunderland Library. All these places are doing stuff.
But if it's cloudy, I don't know what to do. That is disappointment. But I should mention that there is a local connection regarding that, and that is there was an Amherst College astronomer for 40 years, David Peck Dodd. He was, by the way, the other connection that comes in, that he was married to Mabel Loomis Todd, who is responsible for publishing the first set of poems and letters of Emily Dickinson. And there is a whole sort of affair as well where Mabel Loomis Todd was having an affair with Emily Dickinson's married brother, and so forth. So, and it was also well known. This is
that was a total eclipse of the heart, I guess.
This was in the 19th century, and who knows? Amherst was like that in the 19th century. I don't want to say anything about that, but David Peck Dodd actually led many expeditions, solar eclipse expeditions, including the first one he went to. He went for the eclipse on July 29th, 1878 to Dallas.
Wow.
So I consider that sort of like following those footsteps. But then he led eclipses, and in fact, two of these expeditions explicitly had Amherst name on it. It was like the Amherst expedition to Japan, solar eclipse expedition to Japan. He went to Angola, Russia, Brazil, Libya, Peru. I mean, he did amazing. It was an
This
eclipse
all in the 19th
chaser.
Century?
Yes, and early 20th century.
It wasn't easy to go to those places from Amherst then.
It was.
They didn't even have Bradley.
A lot of effort would go in preparing for that, but he's actually more well known for the transit of Venus that happened in 1882, which actually he actually did observe that. But for the solar eclipses, I should mention that, and this is the cruelty of nature, that he did all of these things, and at that time, as we are saying, it would take a lot of effort to go there. He would bring in instruments with him, and in almost all of his expeditions, it was cloudy.
Oh my God.
And in fact, I was reading about it that years after his death, apparently an astronomer ran into his daughter, and he actually said, that your father should be called Professor Todd of the cloudy eclipses. I thought that was a little cruel, but anyway, so that's our local connection. And his wife, Mabel Loomis Todd, and again, I think I've mentioned she was having an affair with Emily Dickinson's brother. Mm-hmm. She actually wrote a book as well, which was called Total Eclipses of the Sun in 1894. She actually accompanied her husband in many of these eclipse expeditions as well. And her final chapter of this book actually opens from a verse from Emily Dickinson, because Emily Dickinson has a couple of verses about solar eclipses as well, and which goes, eclipses are predicted, science bows them in. But then she adds, Mabel, she actually says after that, poets usually care little for the modus operandi of scientific phenomena. The lines above, she's talking about the Emily Dickinson's line, the lines above embrace the fact, the result, the gist of the whole matter, and that ought to be sufficient. But many will desire to know more of the detail. I think it's just so cool. Like, so she's really thinking as scientists do. Like, yeah, but there is more to it, and let's figure that out. And I think, so first of all, this is amazing. Like, that this is our very local Amherst connection. There is a history to that. And both David Peck Dodd, Mabel Loomis Todd were here. But eclipses do provide us with a lot of science, and in fact, some of the most groundbreaking stuff in astronomy is also tied to solar eclipses.
The total eclipse is happening in the afternoon on Monday, April 8th. We here in the 413 are not in the path of totality. Let's say cloudy or not cloudy, depending on the weather, with 95 to 98% coverage by the shadow of the moon, right? That's what, or it's the moon itself. Is in front of the sun. That's the science of what makes the eclipse happen. What will we experience with that level of coverage during an eclipse versus what you're hoping to experience in Dallas or wherever you might go, and Khalees and I are hoping to experience as we are making a beeline towards the path of totality in Vermont?
Right. So you should see wherever you are when the sun is partially eclipsed by the sun. Oh, Bonnie Tyler's song. That was the one that was cut off. Like, no, partial eclipse of the heart.
Yeah, they were like, that was a B-side. It didn't do as well. Yeah.
But you should still be able to, if you look around. So one of the things that people suggest is when you are in the, place of an eclipse, and again, I'm talking about total eclipse as well. It's not just the eyes. I mean, eyes are just one senses. Use all of your senses to experience the eclipse, because especially with totality, you are going to hear insects, for example, start coming out jet normally doesn't, even though it's a few minutes. And again, I went to see the eclipse, the total eclipse in 2017 in Missouri, and this is something that I did not expect, because the crickets started to chirping, and then you have just the temperature falls down, and the atmosphere around you changes, and it's only a couple of minutes, and it's just amazing. So my advice, if you are in the path of totality, is forget about worrying about taking pictures and taking other things. Enjoy it. I've been looking at it, okay, what should I do? And what I've read also, everybody says, just be in the moment.
Yeah, somebody's going to take a way better picture than you are of this thing.
And also, this is a rare event. It's only a couple of minutes long. And this is one of those cases where the reason why we are excited about it, the reason why we are doing it, is because this is one of those instances where we are seeing, hey, you are linked with the cosmos. There are things that constantly happen in the universe, and here you have a chance to experience it. So I would say experience it. So that's the one thing. But before that as well, even if it's 95%, look for what is happening to the shadows. Because normally sunlight comes in and it creates shadows, which is great for trees or from whatever. But in this particular case, the sunlight is itself being blocked by something in front, and that is the moon. And so you will start seeing these shadows that are shape of a crescent, for example, and you will see increasingly. So the total eclipse lasts for about 2 hours or so.
From the beginning of the coverage.
The beginning of the coverage, when the moon starts to cover the sun, that's a much longer period of time. Totality occurs for a couple of minutes. But during this time, you should be able to see these beautiful patterns, and there is plenty of time to think about them, to see them on the ground, look at them, how it is going in. I should repeat, do not look at the sun without the eclipse glasses, but you can look at the ground. Do not look at the ground with the eclipse glasses, because you want to see something on it. So that's what you should be able to see. And it's just, you are seeing action in the universe right in front of you, which oftentimes it will give you a chance to just disconnect from everything that you are doing and just be in the moment with the universe.
Imagine being in like the 1500s or any other time previous to that and an eclipse happened. No wonder people would like fall on the ground and worship a god. You would think God is really mad at you if all of a sudden the sun shut off in the middle of the day.
Not just that. I mean, there are all of these. They're called sort of like the war eclipses or like death of a king, because they would always find something bad happened. Wait a minute, but there was just an eclipse.
Yeah, we'll blame it
or
on the
following,
eclipse.
blame it on the eclipse.
Don't let the eclipse be an excuse to go do something terrible either. By the way.
But I should mention, apart from all of these things, there are eclipses are really crucial for science as well. For example, one of the eclipses in 18 let me get the date right. This was in 1868 in October, and this eclipse, there was a French astronomer who went to India to observe it. And the reason for that was that a few years before that, astronomers had started to use spectrographs, meaning to say they had figured out a technique to look at the light from stars and from the sun and to figure out what elements it might be made up of. But if you really wanted to see around the sun, you needed it to be blocked. And there was an eclipse happening in 1868, and this French astronomer, Janssen, he actually went to India and one of the locations. Well, I guess it was colonial India at that time, so the British were ruling. But anyway, the French astronomer went over there, and he detected a particular type of element in the corona of the sun. So again, when all of the sun is blocked by the moon, you see a little light, a halo around the sun. This is called corona. And actually, it is really mysterious because it is that gas we now know today. It's about 1 million degrees, whereas the surface of the sun, and there is no surface, but the stuff that we see, it's around 5,500 degrees. So we think it has to do with magnetic fields and the sun and so on and so forth, but it's still a really fascinating mystery. But during the eclipse, you can actually see this halo around the sun. And that's so when you were asking what you should see during the total eclipse, well, this is the other thing that you should see. And he used this spectrograph to look at, it analyzed the light from those gases around the sun. And he found this line in there, which people thought that used to be like, that maybe it's sodium and something like that. But actually, no. When he actually took careful observations in 1868, he found that actually it didn't match any of the known elements that were known at the time by science. And that element, Monte, was helium. And hence the name Helium, from Helios, the sun, because they thought, well, it's only in the sun. And this was a major discovery at the time. He didn't know, but actually there was an English astronomer, Lockyer, who actually had done separate observations a little after that, and he actually used blocking the sun and things like that, and he actually also detected helium.
But
And
he detected it in balloons at a child's party. He was sucking them in, and then his voice would change.
But I should mention that both of their papers arrived at the French Academy of Sciences on the same day. And today they are both jointly sort of credited with the discovery of helium, but most scientists did not believe that this was correct because, hey, suddenly a new element which is not found on Earth and it's only in the sun. But however, 30 years later, they found actually gas here around in one of the observations, and that was the confirmation of that. They both got gold medal in 1895 by the French government, so that's amazing. But even this is not the ultimate story of the eclipse, because one of the most famous eclipses happened in 1919. And that is because it's not because of the eclipse that it's famous, but because that particular eclipse provided the confirmation for Einstein's general theory of relativity.
Mm-hmm.
And it's amazing because Einstein had just presented his theory in 1915. I mean, he had been working on it before as well, but in 1915 and 1916, he actually presented general theory of relativity. The basic idea behind that is that anything with mass, like the sun or galaxies or whatever, their mass bends space and time.
Yeah.
And so gravity, in some sense, is this curvature of space-time. Einstein knew the implications of that. And this was all theoretical. So he had just done all the math and he had done that. But where is the test? And one of the ways he had thought about was that if during an eclipse, during an eclipse, the other thing you see are stars. He thought stars that will be behind the sun, which during the daylight you won't be able to see, but during the eclipse, suddenly they would come into view. Their light, when it passes, the light of those stars, when it passes close to the sun, it would get bent. And so they will appear a little bit shifted than they are expected to be. It's just like if you look at, for example, bent, sort of like, stick bent in a pool or whatever. That's another way of thinking about it.
A straw in a water or whatever.
It feels bent. So in the same way, it would act as a lens a little bit. So you would expect those stars to be moved away where they are. And this is a very cool prediction, although Newton's gravitation also predicted some of the bending, not because of the bending of space-light, but because of force of gravity. He thought that light may get bent a little bit, but not as much as Einstein's theory of general relativity. And one of the astronomers led the expedition. He's a famous astronomer, Eddington. He was a British astronomer. In 1919, they knew...
He loves marmalade. Oh, that's Paddington, right, sorry.
No, actually, there's an interesting story about Eddington as well, because he was a Quaker. He didn't want to fight in World War I. He was a conscientious objector. He was a British scientist. And they were like, no, I don't think so. But one of the other royal astronomers, he actually argued that, well, he should be given an extension. And maybe this was in 1918. War was still going on. He says, well, because there is an eclipse coming in 1919, and he will lead an expedition for that. And for this eclipse, there were two places they went. One was in Brazil, and one was on an island off the coast of West Africa. And Eddington went to the island of the coast of West Africa, and the whole point was to check if Einstein's theory of general relativity works or not. It is a crazy thing to do, and if you think about it, that that purely from mathematics, you get a prediction that during the eclipse, you will not find stars in the same place as you expect, but a little bit farther off. And at that time, there is a cluster in Hades in the constellation Taurus. There was a bunch of stars because there was a cluster of stars. And so it wasn't just one star. They could actually measure a couple of stars to do that. And that is what they found. There are fascinating books about this particular expedition because it was, again, it was cloudy, but it got cleared up right at the last minute. They quickly did the observations and so on and so forth. And so that is how, and in fact, it made Einstein a star, even though, no pun intended, but even though Einstein was famous at that time, but not as famous after the 1919 eclipse. It was the front page story in many places. Also because this expedition had challenges because of we were waiting for the war to end, and war did end. And that's when this observations happened. But there was another element to it because Einstein, because of his German connections, he actually had presented his results in Berlin in 1915. And in 1919, he was a British astronomer who was doing experiments, who was doing testing of a theory presented by or calculated by Einstein, who was a German scientist in that sense. So there was a lot of symbolic aspects as well. And so 1919 eclipse, that was amazing.
Are there any things that we think we might learn from this 2024 eclipse scientifically? Are there going to be things that scientists are going to be trying to do that they'll only be able to do because there is a total eclipse happening?
I think the studies of the corona, I think that is still really
crucial.
To
see why it makes us sick and if the vaccine actually is a hoax.
Okay.
Oh, not that corona, I get it.
But yeah, so no, I think those steps there are opportunities for citizen science as well. So again, if you are interested, there are websites for that. Look into that. And I think, I think just enjoy it.
It's a once-in-a-lifetime opportunity, maybe.
And if you're thinking about science, just think about it. how accurately we can predict these
It's
things.
crazy.
I mean,
And even for
terms
hundreds of years we could.
we are talking about in seconds, right? Like, and so, just appreciate. So you are asking, hey, what can we do? Well, appreciate science. Science, I mean, like, there are a lot of uncertainties and all of those things, but there are things that we really know. And just imagine this prediction of Einstein's theory of relativity, how precisely it was like, well, if there will be stars behind it, it will get bent the light from those stars during an eclipse, during those couple of minutes. And then scientists go and measure it, and they go like, aha, that's exactly like. By the way, just close on Eddington, because he also was, he also did, he was funny, he was actually interesting. He also wrote poetry, and so he actually, after coming back from the eclipse in 1919, he even wrote a short poem parodying Umar Khayyam, his rubaiyat, a particular style of poetry, and he said, "Oh, leave the wise our measures to collate. One thing at least is certain: light has weight. One thing is certain, and the rest debate: light rays, when near the sun, do not go straight." So, Eddington is also doing poetry. Emily Dickinson is doing poetry. I know this is one of those things that if you are close to the sun, not close to the sun, but close to the eclipse, you are going to be moved. Try to see the eclipse.